Hey guys, welcome back. As promised, today is the next update video and I will talk a bit more about what you saw yesterday, or if you haven't seen it, you see right now. So, as mentioned, I started my big DC electronics load project. The front panel over here doesn't look too good, but I'm working on it. This thing has to be modified. I have the multi-turn potentiometer. Oh, a very interesting thing, just as I talked about the multi-turn potentiometer. This is my prototype, the small electronics load. And this thing had a multi-turn potentiometer inside. I think it was this one over here. Yeah, it has the cables. And I noticed that the load no longer worked after I used it for quite a bit. And I wasn't sure what happened and did some measurements, and it turned out that this one no longer has 10 kilo ohm of resistance, but more close to, what was it, like 4 mega ohm of resistance. And yeah, it doesn't work anymore, so I might make a quick video opening it up so we can take a look inside, because I have no idea how they look inside, and it might be interesting. So I replaced it with a normal 10K potentiometer, and it's a bit more difficult to dial in the right voltage, but it has its advantages. And the big one, the big load, is also very special. You see, I found out through testing of the small unit that there is a very specific correlation between your potentiometer resistance, the amount of turns you can make, the load resistor resistance, as well as your reference voltage. So if we take a look inside of here, you can see that I have 6 MOSFETs. And underneath each of these 2 heatsinks, I have heatsinks on the load resistors that are used to generate our voltage feedback. And the voltage feedback correlates to the current flowing through them. These are 1 ohm resistors. Now, if you go for 1 ohm resistors, in this unit over here, I first had a 0.1 ohm resistor. 0.1 ohm resistor caused me to, even with the multi-turn potentiometer, a slight turn, and I had huge current spikes. What I then did was install a 1 ohm resistor, but then I was unable to go to very high currents. Well, couldn't exceed like 2 amp. And then I simply made the voltage reference from, well, I have a boost converter inside, and I boosted the voltage inside from the 18650 cells, whatever voltage stays, to 5 volt to 10 volt. And that then allowed me to, well, very precisely dial in with a multi-turn potentiometer the voltage I wanted to have and go towards 5 amp. Now in this case, I'm going for 1 ohm load resistors. And the thing is, when I dial in whatever voltage with the multi-turn potentiometer, I'm going to use one of these because I need the resolution. I will then have 6 times the current that I would have with this one over here, because this one only has 1 MOSFET and 1 load resistor, so essentially 1 rail, and this is 6 times the current. But because a predetermined voltage for the reference that is generated by the multi-turn potentiometer might, well, essentially this makes it very difficult to find a reference voltage that I can use for every current that I want to achieve. So what I will do is I have a power delivery portion that will most likely go in here, because we have fan blowing air in here. So to cool it a bit more, I will have an adjustable reference voltage. And that means I will have another normal potentiometer to dial in my reference, well, not the reference voltage, wrong. The voltage supply that goes to the multi-turn potentiometer, which in return, as a potential divider, makes my reference voltage, that then through the op-amps get compared with the feedback voltage generated by the load resistors. So it's a bit hard to understand. Maybe it's hard to understand. I don't think it is. But essentially I'm going to have two potentiometers, the one that this one for fine-tuning and the other one for wider current range, to extend the current range. So I'm not really limited to whatever preset I have. And as you can see, I have some XT60 connectors over here, and I had to mark plus and minus, or well, plus and minus because I connected them the wrong way around. This is supposed to be minus, this is supposed to be plus, so I don't know what happened, but I stayed true to it, so I don't have to resolder them. I use wires and have everything screwed in place so that it is highly modular, because I always have to assume that something breaks. We have 6 rails. This means I need another 3 op-amps. I don't have the op-amp module on hand right now. This is my power distribution inlet thing with the current shunt for this volt and ammeter, and as you can see, this one is in place. I had this whole, well, I refitted the front plate. The whole enclosure was used before with my first voltmeter, and I simply reuse it. So I had 3 holes in here. This was the grounding hole originally. I don't need it, so I simply use one of these furniture thingies that you can, well, you can hide screws underneath. I have these silver ones, get them in place, and I'm going to insert these banana terminals in here. Then we will have the multi-turn potentiometer, normal potentiometer, and the voltage reference, not the actual voltage reference, but the voltage is generated by the normal potentiometer displayed over here with another small voltmeter. And yeah, so this is that. And as you can see over here, we have fan control. I have 2 90mm fans in here, and they will be controlled by a new fan circuit. Something that I, well, thought about, had in mind, made it, and found out, well, others made it before me. There was, well, when I made the circuit and had it on a perf board, not perf board, no, breadboard, and tested the circuit, it didn't work. And I thought, well, what is going on? Search on the internet, and, well, my circuit was correct, but I connected pins wrong and fried a op-amp. So there will be another video about this one because it's interesting fan circuit. So here are the 2 fans. These will blow in the air. We have the heatsink flipped around, and the whole thing, well, I have to manufacture a backplate, and most likely I'm going to use just some metal mesh, and then this side of the top part that goes all around got modified. I cut out a piece, get some metal mesh in, and yeah, there are only a few things left that I have to do, and then we can finally test it. And I'll make a video and not build in the video so much, but more like show everything more in detail, explain more, because the part with the adjustable voltage, the secondary adjustable voltage, is something that I have to say I never saw. And I also never saw one of these with so many MOSFETs. There might be a reason for it, but I want to try it anyway, and I can't wait to test it. Now, the heatsink, by the way, I bought this on eBay for only €10, and I used a calculator. I have 2 heatsinks, and I was able to determine that this one, when these fans move the air with a speed of 4.5 meters per second through the channels, this heatsink is capable of dissipating 400 watt of power, and only heats up to around 65 degrees Celsius. So we will see if the calculation is correct, but I'm very confident that we will be within a maybe range of plus 10 degrees Celsius. But yeah, so this is the electronics load that I'm working on, and I really want to finish it as soon as possible. Now this can go to the side. As you can see, we have this lying around. That will not be a video. This is something with the GPU repair video. I hate this thing, and you will know why as soon as you saw the video, as soon as I release it. And then we have some power banks. So I'm going to university by now in a few weeks. Wait, it's 18 days. And I have my smartphone, I have my tablet that I need, and I need a power bank so that if I'm on the go and I'm at university for a few hours a day, that I always have enough charge on both devices. So I bought two. I bought this one over here for €10, 20,000 milliamp hour capacity. Very good device. We'll make a video about this. And another one that is like a refurbished one, 5,000 milliamp hours, but very interestingly, it is also a Bluetooth speaker. That was the primary reason I bought it, and also because it only cost €7. That was quite cheap. The unit, if it isn't refurbished, costs I think $19.99. And then we have these monsters. They are DIY power banks from Banggood. They can house 16 cells. I'm not going to spoiler too much, but let me quickly tell you, this one is already filled up. Guess how much it weighs? I'll tell you, it weighs 960 grams. That's almost a kilogram. These are not portable, but they are very nice if you have low capacitance cells that would go to waste otherwise. Yeah, as I showed you before, I still have this small electronics load, and I still love to use it. It's very portable, and that's a nice thing. But because of the thing that I have power banks, and I want to go a bit into testing them, I need some piece of equipment that I can test them. I decided to buy these perf boards with micro USB attached, and I simply get them in here, attach them, cables inside, so I can load 2 ports of one of these power banks at the same time and see when it collapses in terms of current. And then I can determine if they are shared ports or individual ports. I also have these USB testers, but the problem is you cannot fit 2 inside at the same time. As you can see, that doesn't fit, or you can't see because it's a bit too dark. So let me adjust this. So 2 ports, they are too close to each other, and that is the case with most of these devices. So I'll use the electronic slot because I have to use an electronic slot anyway. So what I may end up doing is make a cable so I can go in here to a splitter to these devices, then out to this over here. And I'm going to use the micro USB because then I can use standardized type A to micro USB charging cables to attach both of them. And yeah, there's stuff that I want to do. And right, and because of that I will make a USB cable. I have this over here. Some time ago I bought some cheap USB cables on Banggood. They were crap, but not worth making a video about. Well, I made a video anyway, but I don't think that I'm going to release it. There's not much to say. And then I will simply use some of this cable, get this inside, and I will attach some banana plugs on the other side so that I have one high current capable cable for my DC electronics load, so that I can, if I know that it is a split port, directly test the maximum current capability of the device. And then you may or may not have seen yesterday that I have these things lying around, and I bought a whole bunch of, well, help. These are not capacitors, but these are capacitors. I'm going to talk about this in a moment. A whole bunch of capacitors on LCSC, like huge numbers of capacitors for very cheap money. These are not high quality ones, but these are actually the only new capacitors that I have. And I bought a whole bunch of them for very low amount of money, very cheap ones. And I also bought something else. Let me just quickly grab. So this is all capacitors, different values, and all rated for 50 volts DC. That was this is for me the best multi-purpose capacitor, because 50 volt, I will never exceed this, and anything below it's no problem for the capacitor, and they were super cheap anyway, so no problem there. And then I bought a whole bunch of these things, and these, and this. So this is the step up positive adjustable 5 amp switch, whatever, right, HX3608. It's a boost converter. You know, I was so unlucky with boost converters that I decided in the future I'm going to build my own ones. So I bought these boost converter circuits I'm going to test, as well as, right, these are the Schottky diodes. These are 3 amp Schottky diodes, and these are 3.3 microhenry inductors. So I can make a 3 amp buck converter. That is more than I actually need. I only need 2 amp, but the 2 amp ones that I bought on Banggood were like crap. Oh, and I bought, obviously, a whole bunch of load resistors. Like, huge amounts of load resistors. Each package has, I think, 20 over here, 20 over here, and here we had 20 inside, but I used a few more because when I started the electronics load, I made this prototype, and don't question me on that one. That was absolute, like, oh no. I'm not going to talk about what I did there. That's just embarrassing. This, I have to tell you. This, let me see. Right, this one has all of its legs. So the MOSFET has all of its legs connected correctly, and this one in reverse. I don't know what I thought I was doing, but oh my god. And then I came up with this design anyway, so no problem there. Oh, yeah, I bought this one. That's a small, like, handheld screwdriver thing. I don't know how to call this, but oh my god, I love this thing, and it deserves its own video. I'm using it for quite a few times by now. It's very strong, lithium powered. I want to take a look inside because it has a, well, if it gets overwhelmed, it's only rated for 3 Newton meters of force, of torque. And if it gets overwhelmed, it cuts out. But I'm not sure if it cuts out because of the BMS, or if it cuts out because of a voltage drop, or if it cuts out because of something else that it just forgot. There were 3 things that I was thinking about that could be the case, and I wanted to take a look inside. And this also deserves its own video. Again, I have so many things. And this doesn't really deserve its own video, but I bought one of these. It looks weird, but these are some magnifying glasses that you can wear. You have lenses in here from ×1 to 3.5 times magnification. Get it in here, set it on your head and nose, and oh my god, this is fantastic if you are working even with THT components. Even soldering this stuff over here, I was using the 1 times magnification, and it's awesome. And when I was building this stuff over here, it makes things so much easier, and especially if I'm going to solder like SMT components in the future, I'm definitely going to use this one. I don't know how I could survive without one of these before. Oh my god, I just finished filming, turned around, I thought I talked about everything, and then I saw my other bench and there's even more stuff to talk about. But the video is already long enough, so I'm not going to talk about this in this video. I'll make another one and release it tomorrow or the day after or the day after that or the next week or something. We will see. And talk about even more projects. And what I really have to do is use the community page on the YouTube side. It is finally like accessible to me, so I might start doing like pictures of stuff that I'm working on, make a few comments over there so that everyone knows that I'm doing stuff. If you are interested in projects like these, or these projects, or the ones that I'm going to talk about in the next video, then please stay tuned. And for now, I hope you liked the video, and if you did, please leave a like, comment down below. And other than that, thanks for watching and see you next time. Bye!